Good morning, friends. Thank you very much for joining in to the ETAuto Summit. So, as I said, the world is today volatile, uncertain, complex, and ambiguous, and something which you can't predict the result of the action. And as you see, last year for the passenger car industry was something which was unprecedented. We've not seen in the past so many years. We have seen years of growth in the past 5 years. And suddenly in 2019-20, we saw a dip of about 18% in the passenger vehicle segment. This is on account of increasing vehicle prices, on account of regulations, on account of insurance costs. There was a lot of uncertainty about the BS6 norm and about the implementation of that and what it would mean for the customer. There was also NBFC crisis and of course high interest rates. All of this pulled the market down by about 18%. And we finished the year at 2.77 million. And if you see the graph view down almost to the 5 years ago level as far as the passenger car industry is concerned. Now, what has happened in this VUCA world is that the V has become a double, and the addition of the virus, the COVID-19 crisis, has made the world even more uncertain, ambiguous, which is already very complex, and that's something which is very, very unpredictable in today's situation. And so there are many challenges which we are all are going to face in the current crisis. There is going to be an impact on the India's economic growth. A story which was actually supposed to take off and grow to 5 trillion by 2025, but that's something which is got impacted, and whether it is in the short term, medium term is something we'll have to see. So definitely the GDP growth rate is going to come down. The other thing which is we are going to see is that this is going to impact the various sectors. And if you see automotive, power, whether it's IT system, FMCG, healthcare, telecom, all of this is likely to get impacted. And automotive, where we are talking about, is expected to have a significant impact in current context. And so if you see the industry which had already degrown 18% in the financial year 2020, what it is likely to be in financial year 2021 is something which is very, very uncertain and something which is very, very unpredictable. So what are the things which we expect to change as far as the consumer is concerned? There is going to be a lot of change, and the change is going to be there is going to be a renewed focus on survival products. It's going to be on about sanity, and it's about the change of attitude. When we look at passenger car, it is a discretionary purchase. So in today's troubled times, everybody is looking at saving for the crisis, focus on sanity and survival products, and less expenditure on recreation, and obviously there is absolutely no leisure available today. What we also see is that there is going to be increase in the digital penetration. More people are using and experiencing digital shopping. Each and every one of us has been ordering things online and managing the day-to-day life through that. And digital platforms are likely to increase. And as a work ethic, I think everybody is working from home. And the last 2 months has shown us that there are various ways in which companies are trying to do work from home. There is a huge impact on shared mobility. We always used to talk about, as Maruti Suzuki, we used to say that ACES for India is affordable. It is going to be shared. It is going to be, it has to be convenient, and it has to be environment friendly. So But the shared mobility is, which was supposed to be a big part, it was supposed to take off much more, is going to see a dip. And this is because of the social distancing, and taxi aggregators today may see a lot of degrowth. There could be a possibility that people will come back to personal vehicles, and the demand for for personal vehicles is likely to increase. If you see public transport, I think the social distancing norms are going to impact further. Or the already very short public transport fleet is going to see a lot of impact, and transport, which is actually one, has to need to grow by almost 8 times or 10 times. There is likely to see a lot of growth if we are able to do things right. There is going to be impact on the rural demand. Rural is also a big story as far as passenger cars and mobility is concerned. But today's situation of the lockdown may impact the farmers' income, and there could be a reverse migration, and decline in jobs in urban centers may hamper the growth in the rural centers. And of course, the overall urban economy is going to be impacted by the global recession, and the essential goods and services are going to propel, but restructuring my companies may see a lot of impact on the sector, with maybe in future in many of the service sectors and other industry may see certain job losses going forward. So this is what we see, and this is something which is unpredictable. But there is always that hope that things are going to become different and things are going to change. And we talk about various types of revivals which we have seen in the past. And if you see, there could be various scenarios which would come out, which could be very optimistic, it could be realistic, it could be very, very pessimistic. From optimistic perspective, there could be a rapid recovery. The impact could be maybe the quarter 1 or so, and the macroeconomic impact maybe for the next 9 months, and auto demand may pick up. Could be realistic. The impact could be for almost 6 to 9 months. The consumers may defer major purchases. There could be a significant loss in sales. There could be economic downturn, and obviously the macroeconomic impact could be longer, could be almost 1 to 2 years. And then there is a very, very pessimistic situation where real growth, real structural damage could occur, and long-term growth rate may get impacted. Consumer sentiments are likely to get impacted, and there could be a disruption in the auto supply chain and in the auto OEMs. And the microeconomic impact will be much, much a longer period for recovery. But having said that, what scenario, what we're going to see in future is going to depend on the actions and what all we as stakeholders are going to take. We need to review various aspects, and we need to work with the government for fiscal benefits policies, for future regulatory requirements, and we need to put in our best efforts to bring rapid recovery to the overall economy. What I see is that there are various mobility options for India, and we have seen a change in personal mobility. We have seen a change in the shared mobility. There is things which have been worked on till about in the recent past, till about two months back. New options were being worked out, and shared mobility and pay as you use, those kind of various new areas of affordable mobility was being looked at. And India is, is something, because of our low per capita income, affordability is key, and people do find various types of solutions for this. And going forward, I believe that the consumer behavior may get impacted. There is going to be a lot of change in the consumer behavior, and which would propel us to look at different and more innovative solutions, mobility options. for India. What we need to go back to is the topic of today's discussion, which is virtual simulation, how it is going to impact product development in today's disrupted world. We talked about working from home as a new normal, and that's something which is possible for certain functions, certain areas, service industries, marketing, and some other such areas, finance. But we as engineers, I think our core works start in the manufacturing and in the product development, and how do we skill. And so that's something which is, even though it is said that we are going to have a new normal of working from home, but last 2 months experience has been very, very different. That manufacturing has been zero, near zero, and product development has got impacted, and so has skill development. And these are something which we need to see how we are going to take this forward in such a disrupted environment. And virtual world, how do we use the virtual world? How do we look at some of these things, and how can we use technology to change the way in which we are looking at manufacturing and product development and skill development, is what I would like to talk about from now on. So first, of course, manufacturing, a key point. Auto manufacturing contributes more than 50% of the manufacturing GDP of India. And as we have seen that there has been various changes which have happened as far as the manufacturing is concerned. In the 20th century, it was all about using a lot of robotics and automation and digitization, and using a lot of electronic and digital network. And today we are talking more about IoT and how we can use autonomous machines or big data analytics, or use IoT, Internet of Things, in our manufacturing, make it smart manufacturing, and use machine learning or AI for doing our work. But then, of course, this requires a lot of work which we need to do in terms of what we are already doing on the manufacturing lines, and how do we analyze the data, how do we get the data, and how do we use that and use technology in order to assess it and do automation and do machine learning, so that we are able to predict and do certain things. When we are looking at manufacturing, I think that's something which is already evolving, and which I think is going to further evolve with social distancing norms becoming a new reality going forward. And of course, this is something which it's in the medium term or short term or long term, is something which nobody can predict till we get a vaccine or something like that. But this is something which we need to look at. And if in today's context, when we have started manufacturing in Maruti Suzuki, social distancing has been one of the key changes which has happened, which has impacted the productivity and some of these things going forward. And how do we recover, go back to that, is we need to look at by using technology and putting in more automation and some of those things is one way forward as far as the manufacturing is concerned. But that's one whole new big topic which is there. But today I would like to focus more on product development as engineering. I think one of the key things is that when we look at model development, one of the key things is we look at design and we look at engineering and evaluation. So first part is the design, and when we are looking from a customer point of view, what does a customer need as far as product is concerned? The designer looks at the concept and starts sketching, and from the sketch he makes a 2D sketch and then makes it into a CAD model. The current development philosophy, as you see on the slide, is that we are using various stages, and so we use a combination of CAD modeling and physical modeling in order to come to a conclusion and to come to a final model which can be approved by the management. And it goes through an iterative process. Is this iterative process is it very good in terms of efficiency? Definitely not. It takes time. And so what do we do as far as improving the efficiency is concerned? So, the designers and engineers work towards how do we adopt 4.0 approach towards this? How do we reduce the the development time? And the major focus is on use of virtual reality and augmented reality. And if you see that there are stages which can be removed by using a lot of virtual reality or augmented reality, and only make only one model, which is the final model. So we have to make only one final model when we are doing this. I think the key point is that how do we, improve our judgment capability when we are looking at, AR and VR? It's very, very difficult for management and for marketing and other people to be able to appreciate how designers will be able to view these rendered models in such a virtual reality atmosphere. It requires a lot of skill and lot of capability to be able to take the right decisions in terms of whether the design is okay or not, and what kind of gaps are acceptable, not acceptable, and what is the kind of quality, the perceived quality of the model is something which is always questionable if the judgment is not okay. So I think the key point is that are the people who are going to be judging and who are going to approve the model, do they have how will they develop this capability of using such virtual reality tools to be able to take judgments which are going to be accepted finally by the customer? I think that is something which is a gap which is there, which means that there is a lot of skill upgradation and capability upgradation has to be done by the design team and by the management team. These are tools which are available today, and people can actually start doing this. Everybody is using it world over. Many people also, many OEMs also don't do a final mill model also. They just go directly to data and then start the engineering process. So I think that's something which we need to look at. And after all, it's all collaborative engineering, and even at these stages, the engineers are also looking at the data and seeing what all is manufacturable, and engineering wise, is it okay or not. So I think it's something which we need to work out, and so that's one part of the design. I think, and here the key point which I take away is how do we improve our judgment capability in order to say that this design model is good to go for finally to the customer. I think that's where the challenge exists, is my belief. The second, we'll move to the engineering aspect of it. And why do I say this? If we are going to make changes after we do the prototyping and we and or in the first build, we find out that there are problems. What you typically see is that you have to do a lot of engineering changes, and what would that mean is that it is an iterative process, and then you end up taking much longer, and which is a very, very conventional approach. So our thinking is always how do we front load some of these activities and make it go forward in the concept stage and 3D modeling stage, and get in all the engineering inputs and make sure that everything is okay. So I think that is something which we need to do. And as I explained in the earlier slide, the design process is not robust enough. There could be a lot of engineering changes later on. And so therefore, I think that robustness is something which we need to do. A similar kind of thing applies to the engineering, because after the CAD data is released by the designers, the engineering teams have to convert it into 3D data and have to convert it into actually drawings and do the computer-aided engineering analysis and see various use cases to see, and which we'll talk about in the next couple of slides. So I think that's something which is very, very important to see. The key point here is we can reduce the development time if we are able to front load the virtual validation and going forward, that is the way forward. And that's something which we all need to see how can we improve our use cases for doing that. I'm sure today's conference is going to be talking about all of that, and you are all going to hear a lot more about some of these detailed topics going forward. But I'll touch upon some of these in my next slide. So when we are talking about simulation, and this is something which every organization has to do, that whatever is the data which is made, virtual simulation for crash, NVH, durability, powertrain, CFD analysis, these are something which we all need to do. We need to do simulations, and there could be, it could be again an iterative process. The iterative processes are because the model capability or the correlation with the physical testing is not good enough, or the model itself is not very robust, or the engineering needs to be more robust so that the results which are there are much better. When we are doing the engineering and we are doing the CAE analysis, all of this happens in a closed loop, and of course manufacturing engineering is also a part of this, because what they are going to do is that they are doing the digital mock-ups. They are going to do a check on the virtual production assembly lines, or doing virtual assemblies, or doing the weld engineering mock-ups to see what kind of access of tools is there, and what kind of how do we make the engineering which is done by the R&D acceptable for the production lines. I think that is something which is a very, very collaborative effort. It happens virtually, but there are a lot of things which come out, which is in terms of problem areas which come, and those are many times found at the time of the prototype stage, or during manufacturing, the first build, or the production photo, or the mass production photo. The key point is how do we minimize all of that. So there are two aspects to what I am talking about as far as the virtual simulation is concerned. One is from the engineering aspect, that how do we improve our capability to improve the crash model, the NVH model, the durability, the powertrain model, the CFD models. That is one. The second is how do we improve our capability to do virtual assembly, virtual welding, or virtual production assembly. These are some things which we need to improve. This again comes to the fact that how well the engineers are able to judge what kind of the DFMEs they are able to do, or what kind of PFMEs they are able to do, so that they can make this whole thing very, very robust. And if they are able to improve the models, then there is a high probability of 90%, 95% correlation that there will be very few engineering changes when we actually go into the build stage. So this is one aspect of the virtual simulation. But then one key point which is there is that there is still today, when we are talking about product development, the validation is something which is very, very important, and which is actually physical validation. The physical validation model of models is something which is very, very important, because the virtual validation is maybe about 85%, 90% correlating to the physical testing, but the physical testing does throw out certain issues during the actual build and during the actual testing, and there are defects which come out, so that we need to take countermeasures, so that do the engineering changes, so that ultimately when the SOP happens, the customer gets a trouble-free product. So I think that's something which we all would like to strive to. And like what I explained in the simulation, we anyway, of course, we are going to do the crash and offset and side impact and pedestrian and so on and so forth. All of these testings. But the key point here is that how do we get all of these data points of our testing and the variables of the road surfaces, or the way in which the customer is using, how do we build it back into the CAE model? If we are able to do that, and if we are able to build this back into the CAE model, then I think the correlation starts improving. And if we are able to achieve a 95, 100% of this, which is very, very difficult, because there are so many other variables which are there, is something which we need to strive for in today's situation, so that we can reduce the product development process. There is also this thought that there should be virtual labs, and so the labs should be able to do the virtual testing. And so how can we convert these instead of doing road tests or doing endurance, where actually on various things, can we move it to a different way in which we can create virtual labs so that we can reduce prototyping and physical testing. This is something which we'll have to work on further as the testing teams, the engineering teams, and the validation teams, the CA teams will have to work together to see how we can create certain futuristic virtual labs which can actually reduce it. So this is something which we need to strive for, and this is an opportunity today which is available to us because what has shown in the last 2 months in the lockdown, we were not able to do any of the prototyping or the physical testing in the last 2 months of the lockdown. But yeah, the engineering work was happening. We were able to do a lot of work through the VPN access or shifting the our workstations to the engineers' homes and doing all of that. The CAE team were also able to do. But then lot of collaborative work with suppliers and all of that got impacted, and the physical testing at suppliers and or at our end as the OEM has also got impacted. I think that's something, even though this is likely to be a futuristic, new normal, but this is something which we need to account for, that how do we do the physical testing, and how do we catch up now and the product plans going forward is something which all the engineers are working going forward. I think so. Virtual labs could be one possibility going forward, which could actually improve the further our robustness of the CAE and the simulation, so that they could be, we can in such uncertain times or in such crisis, we can actually do certain work and still do our product development on time. The third fact, of course, is how do we develop the skill in the organization? And this is something which we all need to work on. And I think engineers, when they come to college, they do classroom lectures. Today, it's moved to e-learning, and they are going through some experiential testing or some other labs in their college curriculum. But when they come to the industry, they actually have the experiential learning when they work in the R&D centers, in the testing centers, and while they work in the industry. But I think there is a likely change which is going to happen when this experiential learning is going to change to a knowledge-based management and knowledge-based learning, where there is a lot of information, data of what all has happened in the past, that and various use cases which are there, and what kind of countermeasures were taken, so that the people are able to, the engineers are able to learn it much faster. I'm not very sure how this actual experiential working with the hand is going to get switched over when we move to physical labs or using only AR and VR technologies, because unless we are actually doing work with the hands, you're not able to actually judge it better. But then if this is likely a new normal, and this is something which we need to look at in future, that is something which we need to develop a skill and a capability in organizations, that how can we move from the experiential learning of working with our own hands to more physical labs using AR and VR technologies. These are something which we need to look, and I think the key point is that organizations need to be able to do proper evaluation and develop the judgment skills to be able to move towards these, because technology today can be made, visualization is possible, but the judgment based on the visualization is something which is very, very key, and those are things which engineers need to work and look for going forward. I think in the midst of this crisis, I think all of us have learned to work in a very different way in the last 2 months. And I think this crisis has given opportunity for all of us to look at very, very differently. It is an opportunity for engineers to set the new normal, look at more innovative solutions going forward. It is also a great opportunity to develop new technology and use a lot of AI and use a lot of VR technologies to look at product development in a very, very different way. And I also believe that India is very unique, and The challenges are very unique, and we always find local solutions for in India. I think the engineers have an opportunity today to look at it very, very differently. I believe that this is something which we need to all try for, look for, find the opportunity in today's crisis to bring back the mobility industry back on track, find innovative solutions, uh, find innovative solutions for our work, find innovative solutions for the customer, so that we are all going to be reliant, because if any economy has to survive, I think people have to move to be able to make it for their economic activity. And we as engineers need to provide those solutions for India. So I think today's web seminar, which all of you are going to be participating in, is going to be a unique opportunity where we are going to learn, listen, think of new ideas, and see how we can change the way we look at mobility and the way in which we are going to propel India going forward. So let's all change to build a new self-reliant approach and fight the existing reality. Thank you.